So we're asking about this idea of AC supply and DC supply. If we've got a DC supply to our phones so we can charge up our phones, what's going on there? We get the supply to our phone charger through the wall, most likely, and that's going to be an AC supply. It's going to be a 240 root mean square AC supply, and our PowerPoint that I'm about to show you talks about that. Okay, a 240 root mean square. Now what that really means is that the voltage in the wall sockets is cycling in its orientation, positive, negative, from the two pins there. And what we're also going to see is that it's not cycling between 240 and negative 240. It's cycling between, I think it's about negative 340 and positive 340, approximately. The numbers are not exactly that, but that's approximately what they are. So that's cycling through. So we're seeing a sinusoidal supply coming from the wall. But then we get our charger, and our charger supplies a DC supply to the wall. And the reason I'm holding this in my hand is that this is an example of, this is a voltage supply that high schools have all over the shop. And what's really great about looking at this voltage supply is you have DC and AC supplies there. The yellow pins indicate AC supply, and the red and black pin indicate DC supply. What do you know about the pictures between the yellow pins? What do you see there? Yeah, it's a classic sinusoidal wave, isn't it? Now, what do you notice about the picture? I'm seeing my chin in the image, really. What do you notice about the picture between the red and the black pins? It's an absolute value version of the sinusoidal wave. This is a classic rectifier. It takes that AC supply from the wall and just flips all the negative values. So you don't actually get a steady state constant voltage from one terminal. Now, wherever you've got a rotational, so wherever you've got a rotational form of EMF supply, and that's going to be coal-fired power plants, gas-fired power plants, that's going to be oil and diesel-fired power plants, that's going to be wind turbines, they operate off coils as well, that's going to be wave-based generation, that's going to be tidal generation, that's going to be hydro generation. All of these power supplies are working off of making something spin. You know, in the case of your coal, gas, oil, diesel, they're all working off heat, so they're generating heat. Nuclear, they're all generating heat, which then causes something to spin. In the case of wind, the turbine, the veins of the wind turbine cause the coil to rotate. So that's kinetic energy from the air causes it to rotate, and so you get the sinusoidal supply. In the case of wave generation, if you can imagine, if I'm correct, and I might actually be wrong, if that's the seabed, you'll have some sort of anchorage point. You'll have then some sort of piston, a float. The waves come through, lifting the float up and down, causing this, whatever's in here, attached in here, to go up and down, which cranks a shaft, rotates. It's still a coil that's spinning, and then that creates an EMF somehow. That's an engineering question. I don't know much about that. I won't go into it too much. Okay, sorry? That's the thing. Yeah, wave powered is definitely an option. We were looking at wave powered generation off the coast of Albany for a while there. We were hoping to do that there. Off the coast of the Northwest Shelf of WA, we sometimes think about using that arena for tidal generation because we have massive tides off of that coast up there. And those massive tides, you have surges of water going inland first, can spin a turbine to make electricity. And then as those surges of waters recede, they can spin the coil again to make surges of electricity, which is fantastic. And again, it all comes back to rotation. The only time we're going to see a steady state direct voltage, where it's just a regular direct voltage, is where we have solar panels. So solar panels, that's where we see a steady voltage in one direction DC supply. Yes, very good point. So batteries are also positive constant voltage, one direction, which obviously diminishes over time as the battery expels itself, but yeah. Your charger for your laptop, your charger for your phone, is taking this AC supply at 240 volts root mean square and transforming it into a lower voltage, which is safe for your laptop to be charged on, and also rectifying it. So we've got two things happening in this little box. One, it's transforming the voltage down. We haven't learned about transformers yet, but we will soon. And two, it's rectifying the voltage, so it's not just positive, negative, positive, negative, positive, negative. It's rectifying it so it's only a DC instead of an AC. Okay, so I just thought that would be worth talking about. Is that okay, what I've said there? All right.